All right, everyone, let's get right into CS50 Week 7 SQL. So SQL is standard query language. We're going to get into using SQL to look at a few different databases to practice getting data from those. So taking a look at Lab 7, we have songs. What's cool about songs is that we're going to use, or we're rather going to create SQL scripts to get different songs based on specific prompts that we have for this assignment. So we actually have 8 different prompts seen right here. And we're going to go ahead and go right into the code for looking like what those look like when it comes to actually implementing them in SQL code. So for prompt 1, we want to write a SQL query to list the names of all songs in the database. This one's really straightforward. So the database contains a few different tables. So I can go ahead and run into the terminal and check that out. So let's go ahead and change directory into songs. And then let's do SQLite 3. And then we're going to do the database, which is called songs.db. Just had to double check that. All right, so let's go ahead and run the schema. So now that we've run schema, we can take a look at what the songs database actually contains. So it looks like it contains 2 tables. The first table is called songs, and it has different data like the song ID, song name, artist ID, a few other values for songs. And then in the artist table, it's really just 2 columns. So we have ID and name. So what we want to do, keeping in mind the prompt, which is to get the names of all the songs, we want to select name, which is a specific column in the songs table. So we want to select names from songs. And of course, songs is this table right here. So once we actually run that and see how it looks, we can check that out. So we can just go ahead and say select name from songs. Then we want to put the semicolon. Awesome. So that worked out perfect because this is exactly what we want. We want to see the names of all the songs in the database. So we can continue to move along. So going to the prompt number 2. Prompt number 2 asks us to write a SQL query to list the names of all the songs and increase in order of tempo. So the way that we can do that is essentially to select the name of each song from songs. And keep in mind, songs is the name of the database, but also the name of one of the tables in the database, as we see up here. So what I mean is songs.db is the database, but songs.db contains 2 tables, namely songs and artists. So just wanted to recap that real quick. So from the songs table, we want to select the names and order by tempo. Let me double check, is that correct? Yeah. So we're ordering by increasing order of tempo. So if we go back to the SQL query we're writing up, that will do it correctly. So we can go ahead and execute that. And I'm going to do it this way. So let's do Control-C. Oh, you know what? I'm pretty sure I'm using this pen, and I'm hesitating because I'm pretty sure this has a right-click function. Okay, let's see if that works. Okay, so it looks like I still have to use the keyboard for putting into the terminal, which is totally fine. So let's go ahead and do that. Select name from songs, order by tempo. Cool. And then that's going to do what we want there. And then I'll quickly run through the other remaining ones as well for Lab 7. So for the third prompt, what we want to do is we want to write a SQL query to list the names of the top 5 longest songs in decreasing order of length. So to actually implement that, it's going to be pretty simple. Again, we're going to select name from song, so select the name of every song. But here we're going to order by the duration, which is another name for length. And then we're going to order it in a descending way. So that's what the DESC, sorry, is for. And then we want to limit 5. So we don't want to display all the names of all the songs. We just want the top 5 longest ones in descending order. So that'll work for that. For prompt 4, what we want is we want to write a query that will list the names of all the songs, or any songs rather, that have danceability, energy, and valence greater than 0.75. So we can check out how that's going to look right here. So we're going to, again, select name from songs where a few different conditions are all true at the same time. Danceability is greater than 0.75, and energy is greater than that, and valence is greater than that. So once we run this query, we'll see the names of the songs that work for that. Okay, let's go to number 5. So number 5, we want to write a query that returns the average energy of all songs. So there's a few ways to do this. Probably the simplest way is to just select average energy as average energy from songs. So average is a function that we can just call on to take the average of all the values from a column in a specific table. So what we're doing is from the songs table, we're taking the average energy and then we're selecting that as average energy. So that's just going to output it. The reason we do it is because it's going to output it as a nice setup right here. So let's go and run that. Select average. Oh. Just to see how it'll actually look. Yeah, so we can see that it's just going to output a single value for the average. And it's called average energy. Keep in mind, average energy isn't actually a column in the songs table. It's instead going to be a sort of stand-in that we declare right here. So that's kind of cool. If you want to get a value and then call it something specific, you can do it that way. All right, so taking a look at prompt 6, we want to write a SQL query that lists the names of the songs that are by Post Malone. And we can do that by basically doing this notation here. So if we do select songs.name from songs and we join artists, what we're doing with the join is we're joining these two tables together. So now we're incorporating not just one, but 2 tables, so both tables in the songs database. And the notation for getting columns from a specific table is this notation right here. So we have the table dot column. So in this example, songs is the table, and then name is the column. And then same here, songs table, artist ID is a column, and then artist is the table, ID is the column of artist. So that's what that notation's all for. And then we're going to do all that where the artist name equals Post Malone. And then when we do that, it'll show us all of the names of the songs sung by Post Malone, which is pretty cool. Doing that just in SQL. For prompt 7, we want to write a SQL query that returns the average energy of songs that are by Drake. So we want to basically output, oh, my bad. Sure, apply changes. Okay, we basically want to output, oh, you know what, actually, I'm going to do that here too. That way it's, yeah, this is a lot cleaner and easier to read in one go. So we want to output, similar to average energy as before, a single value by doing this script here. So let me go ahead and do that. Sorry, my alarm went off. So let's see that in action. Yeah. Sweet. So this is just going to output the average energy, and we can even make it more descriptive. Like we could if we wanted to say something like this, we could write it as select average energy as Drake's average song energy, something like that. Or even better, yeah, Drake average song energy. And then if we just run this, Drake average song energy. Hang on, let me see why this is not wanting to go. Oh, gotcha, because it's got to be one string. Okay, let's do that. So let me change this real quick. So we're going to do Drake average song energy. We are debugging on the fly, live. I like it. All right, and then if we do that, okay, cool. That's what I was intending to do. So if you wanted to, you could have it output the average value as a variable name that's a lot easier to understand what's happening. So here we have Drake average song energy, so that's a lot more descriptive than just average energy. But that'll work great for that. And then for the last one, for the lab 7, for prompt 8, we want to write a SQL query that lists the names of the songs that feature other artists. And this is actually pretty straightforward to do. So we want to select the name from songs where name like this notation. So what this notation right here means is essentially we want to, for any song name in the database, we want to look at whether it has the letters FEAT and period, because that'll basically tell us, okay, this song features someone else. And the way we can do that is by putting a question mark before, or I mean, not question mark, a percent sign before and after. So that's kind of like a wild card. It's like saying, we don't want to look at the very beginning of the name or at the end. We just want to see if feet is going to be anywhere in the name. So that's what's happening right there. So that's actually going to do it for lab 7. Let me go ahead and move a little bit to not practice set 7, but actually to the problem sets. So I'm actually not going to talk about movies right now, but I'm going to talk a little bit about Fiftyville. I think movies is actually pretty straightforward. If someone works through songs, then they're going to be able to do movies, no problem. I think Fiftyville takes a little bit more time to think through, and I'm not going to talk about the entire solution here because I don't really want to give it away, like even for people who have already finished it. But I think it's worth talking about at least the beginning of it. It's also just a really good exercise. I think they did a great job at CS50 of making Fiftyville, because it's pretty cool to go through the steps of trying to solve this puzzle using just SQL. So let's go ahead and get into it. For Fiftyville, one thing that helped me a lot was taking a ton of notes and recording those notes in the comments directly in my SQL log. So the very first thing I did was I wanted to assess crime reports from July 28th, 2021. I wanted to see what's happening in terms of crime going on that day and whether any of those crime reports can help us figure out the next step for digging into what happened. So after I ran this query, and actually, yeah, just a brief note on the query. So crime scenes reports is one of several tables in the Fiftyville database. And then description is just one of the columns. And I'm doing where year, month, and day. So in the where function, I'm basically looking for a specific day using this notation. So that ended up working. And what I found is that there's more descriptive information in the crime report about the duck robbery. So the theft of the CS50 duck took place at 10:15 a.m. at the Humphrey Street Bakery. interviews were conducted today with 3 witnesses who were present at the time. And this is not my writing now. This is actually this is a description of the duck robbery. So I'll continue now. Each of their interview transcripts mentions the bakery. Based on this information, I will try getting the activity and license plate. Oh, now this is my writing. Okay, yeah. So let me just make that a little bit clearer. Log, crime log, and then my writing after that. So based on this information, I wanted to try getting the activity and license plate data for any events which took place at 10:15 at the Humphrey Street Bakery, because that will give us more insight as to who could have been a contender for stealing the duck. So what I did is I selected activity and license plate as well as hour and minute from bakery security logs, where year equals 2021 and month equals 7 and day equals 28. So this is basically looking at the same day with an additional piece of information using the hour that we got from the crime description, while looking at not the crime reports table, but now we're looking at the bakery security logs table. And then from that, I was able to discover that there were 2 entrances and 1 exit took place between 10:08 a.m. and 10:16 a.m. Our thief is likely one of these individuals. Let's look at the interviews to get more data. Specifically, I'll search for the bakery keyword anywhere within the interview transcript. So then I select the name and transcript from the interviews table, where the date's the same and the transcript like percent bakery percent. This is again kind of like the featuring thing from songs. This is just going to see if bakery is anywhere in the transcript. So there are a few different results that I can talk about. So I'll just read them off, just straight up, or I'll instead actually just summarize these. So from the query, there's basically 3 people that mention bakery, and there's Ruth, Eugene, and Raymond. And then I mentioned now we have more details about the timing of the robbery in relation to security cam footage. And then a detail about the ATM withdrawal by the thief and the accomplice. So then what I do next is I go back to the security cam footage and extend the search to be within plus or minus 10 minutes of 10:15 a.m. So I go ahead and run through that. What I found is that there's a few possibilities. So I just want to continue to gaining more data. So I do that by then looking at ATM transactions which took place on that day, where the location is Leggett Street. And why Leggett Street? Essentially, yeah, I actually don't remember where I found out it's Leggett Street, but, oh, right here. Yeah. Eugene says, I was walking by the ATM on Leggett Street. Okay, cool. So I know it has to be that one. Then I plug that in. And then this ends up yielding 8 possibilities. So I continue this query with a larger query. This query selects people who conducted an ATM transaction on that day and whose license plate showed up in the bakery security logs between 9 and 11 a.m. So this is guaranteed going to tell us who is one of the final contenders for who's going to be the thief. So this is a big query, but it's actually kind of straightforward what it's doing. So first, we want to select the name column from the people table. And then from ATM transactions table, we want to join bank accounts where bank account number equals ATM transaction number. We want to join people where people ID equals bank account person ID. And we want to join bakery security logs where bakery security logs license plate equals people license plate, where the ATM transactions occur on this day, and ATM transactions is Leggett Street, and then narrow it down to between 9 a.m. and 11 a.m. ordered by bakery security logs minute. And this is going to do a great job of telling us what who is or who's going to be one of the final people that's going to be considered for the robbery. So that's all I'm going to talk about for 50Ville. But I hope that was helpful just to get some insight as to how I did the code, and let me know how you solved it and how you would recommend maybe some improvements for or ways that helped you to do it quickly. Thanks so much for watching.